My name is Driscoll and I'm an analyst in the site assessment department here at BlueFloat Energy. I studied industrial engineering at university where I specialised in control systems and automation, where I learned some of the skills I used to carry out many of the tasks I perform here at BlueFloat Energy, including modelling, optimisation and data analysis. I've also worked in the research and development of battery-based energy storage systems and their applications, such as renewable energies. So at site assessment, we look to support the company's business origination and project development activities in a variety of ways. On the one hand, we look to carry out detailed site screening analysis and mapping for our current and future projects, determining maybe what constraints are present and also looking to determine the optimal size and location for these projects. On the other hand, we carry out energy yield assessments, we perform layout optimizations, and we look to assess the meteorological conditions at the site, both wind and oceanic, metocean for short. We estimate design variables in both normal and extreme conditions, which is essential for the basis of design of projects. These are some of the most important activities we carry out, as energy generation is directly linked to the financial viability of these projects. For these tasks, we use a combination of commercial softwares and tools developed in-house by the team. Well, generally, floating offshore wind benefits from better wind resources, increased atmospheric stability, and less interference as it tends to be located further from shore. However, the main advantage of floating offshore wind is the potential to unlock areas previously unavailable, such as the Mediterranean, where shallow water depths are scarce and therefore there is much untapped wind resource. However, there are challenges facing floating offshore wind in this aspect, such as challenging ocean conditions which can hinder turbine and floater stability, which can lead to increased downtimes in generation. Overall, we believe the pros outweigh the cons, and which, coupled together with all the other advantages floating wind has to offer, the future looks bright for this technology. So the site assessment process has many steps and they tend to vary on a country-by-country basis, but overall the process looks something like this. First, we look to align ourselves with the different country managers and regional VPs to gain a better understanding of the business development plans and the type of process. Maybe if this is a country-wide or a local assessment, or whether this is a business origination or tender process. Then we look to gather as much information as possible about the area, including existing infrastructure, so ports and water-grid interconnection, determine if there are conflicts with other ocean uses, maybe fishing or shipping, and assess the site conditions, water depths, deep-bed geologies, and the wind and ocean conditions, of course. For this, we employ GIS, Geographic Information System software, to bring it all together. Then we look to carry out technical commercial assessments, which can produce heat maps, allowing us to determine expected energy generation, capital expenditures, and levelized cost of energy values. Then we carry out layout optimizations, in order to determine the number of turbines and their placement. This is a balancing act as we look to strike a balance between wake effect losses, i.e. how turbines affect each other within a wind farm, and other aspects such as costs, generation, and therefore profitability. So overall, site assessment is a highly iterative and multi-criteria process in which we look to produce both a qualitative and quantitative assessment, able to assist the company in making informed decisions on project development. So a FLIDAR or floating LiDAR device is a buoy that uses light detection and ranging, a technology similar to sonar and radar, in order to obtain accurate atmospheric measurements. The buoy is also fitted with a series of sensors that enable us to obtain measurements on waves, currents and water levels, amongst many others. We typically employ FLIDARs in 1 to 2 year measurement campaigns in order to calibrate long-term satellite wind and oceanic data. This is essential for the latter stages of projects to reduce uncertainty and produce bankable assessments for our projects. So overall, FLIDARs have shown to be an accurate, cost-effective and environmentally friendly alternative to traditional offshore met masts, which required time-consuming on-site engineering. Therefore, BlueFloat Energy has embraced FLIDARs for its measurement campaigns and has extensive experience with this technology.